Okay, thank you. So what I want you guys to do right now is to draw this free body diagram of this case. Okay, in order to draw the free body diagram correctly, we have to remove all the constraint. We are not supposed to draw the constraint anymore, but we have to replace the constraint with the reaction force, which is caused by those constraints. Okay, now Aryoga, at point B, is there any rotational restriction because of pin B, Aryoga?
No restriction because of pin B, but there is restriction because of A.
Because of A, yes, but we don't have. I don't want to talk about it. I want to talk about the point B first. So
Okay.
at point B, there will be no restriction of the rotation, right? And there will be no rotation restriction, right, Aryoga?
Yes.
Okay, but that pin at point B will restrict movement horizontally and vertically, correct or not?
Yes.
At point B. Okay. Because of that, we have to replace pin at point B with a reaction force, vertical and horizontal, because as you told me just now, it restricts movement, vertical movement, and restrict horizontal movement as well. Do you get it, Aryoga?
Yeah. So the pin joint only allows for rotational movement.
Yes, correct. But it will not allow for horizontal movement and vertical movement. That's why we have to draw this too, in order to restrict those movements. Do you get it, Aryoga?
Okay. Yes, I get it.
Okay. So basically, this is how we supposed to replace the what you call it, the constraint. Yeah, how we supposed to replace the constraint with the reaction forces. So try to take a look at that constraint. What kind of restriction that constraint makes? For example, at point B, it's a pin joint. The pin joint will give you horizontal restriction movement and vertical movement restriction as well. Because of that, you can replace pin at point B with these two forces. Okay.
Can I ask?
Yep.
If the forces, the 200 Newton and 100 Newton was from the bottom to the top.
Who's talking just now?
Me, Alberto Hans.
Alberto. Okay. What is not directly going? Okay, Alberto. Would you mind to turn on the camera, Alberto, when you talk to me? So I can see your face, yes.
Okay.
Yeah.
So can I ask if the 200 and 100 Newton is going the other direction, like to the top, will Bx and By be the other way around also?
It's not necessarily like that, because 200 Newton is going down and By is going up. It's not just affected by the 200 Newton. Okay, By going up will be it will get affected by all the other forces as well. Do you get it, Alberto? So basically, when you draw the external forces, when you draw the reaction force Px and By, the direction that you draw them is actually up to you. Okay, as long as By is vertical and Bx is horizontal. By can be going up or going down. Bx can be going to the right or going to the left. It's up to you guys. Okay. Later, if the direction is wrong, okay, you will get minus results, and it should be okay as well. You just need to let let the teachers know when in your answer later that okay, the value negatives because the direction is supposed to be the opposite of what I draw in the free body diagram. Do you get it?
Yes, sir.
Okay, good. Okay, Alberto. Now, because just now you asked me, but try to draw the reaction force at point A. because of the roller at point A. I want to replace the roller with reaction force. And what I supposed to draw there?
The AX and AY.
AX and AY. Now, okay, let's retract a bit. Okay, point A is a roller joint, right? We talk about it, right, Alberto?
Yes.
Okay, roller joint can restrict the movement in the vertical direction, but it will not restrict the movement in the horizontal direction because it's roller, right? When we talk about roller, when you push horizontally, it will move. Correct, right, Alberto?
Yes.
Okay, in that case, should you add the horizontal reaction force as well or not?
All right. So just AY, no AX.
Just AY, because it's only restrict vertical movement. Okay, so basically, when we draw the free body diagram, try to take a look at the constraint. Okay, what kind of restriction that the constraint makes? For example, at B, the restriction is a horizontal movement and vertical movement. Then draw the horizontal force and vertical force in order to make that restriction. In order to replace the pin. Okay, now take a look at point A. At point A, there is a roller joint. Okay, when we talk about roller joint, okay, it will not give horizontal restriction because when you push horizontally, it will move. But if you push vertically, it will not move. That's why it will give vertical restriction. Because it gives vertical restriction, then you can replace that roller joint with vertical force AY. So this is actually our free body diagram, which completed with all the forces happening to the beam. But okay, remember, free body diagram is not just necessarily have to be completed only with the forces, but you have to complete it with the dimension as well. So in order to draw the correct free body diagram, you have to draw the dimension. Okay. So basically, free body diagram is a tool to help you to solve the problem. So all the knowns value supposed to be there. All the unknowns value supposed to be there as well. So we have to draw, okay, here from here to here is 2 meters. What else? Okay, from here to here is 3 meters. Okay, and then from here to here is another 2 meters. Okay, and half of the thickness of the beam is 0.4 meter from the middle. Okay, from the middle to the top, the thickness will be 0.2 meter. The pin joint and the roller joint is happening at exactly in the middle. Okay. Now we have a complete free body diagram because we have all the dimension there and we have all the forces happening to the beam. So this is how you're supposed to draw the free body diagram correctly. You have to put all the known forces, unknown forces, and all the dimension you're supposed to put it in the free body diagram. Okay, so you have to remember that. And beside that, you cannot include the constraint over there. Okay, you cannot include the constraint in the free body diagram, but you have to replace the constraint with the reaction force due to that constraint. That's why at B, instead of drawing the pin joint, I draw Px and Py, force Px and Py. And at A, instead of roller joint, I draw force Ay, like that. Okay, is it understood, guys? Do any of you want to ask questions? Okay, while waiting for you guys, I will re-explain this in Bahasa. Okay, Jadi cara untuk menggambar free body diagram yang betul, diagram benda bebas yang baik dan benar, itu adalah kita tidak bisa menginclude, kita tidak diperbolehkan untuk menginclude constraint, pin join, roller join dalam gambar free body diagram kita. Oke, tetapi kita harus mengganti constraint-constraint tersebut dengan gaya-gaya reaksi yang merepresentasikan constraint tersebut. Contoh di B itu pin join itu menahan gerakan arah X dan Y. Oleh karena itu kita munculkan gaya BX dan BY di titik B. Tetapi pin join-nya kita tidak perlu gambar lagi. Tidak boleh digambarkan, hapus. Lalu di titik A, roller join itu menahan pergerakan ke arah Y, vertikal. Oleh karena itu kita gambarkan AY di sana. Roller join-nya tidak boleh kita gambar lagi, kita hapus. Oke. Selain itu, dalam suatu diagram benda bebas yang baik dan benar, itu semua gaya-gayanya harus digambar, baik yang diketahui maupun yang tidak diketahui. Oke? Yang diketahui kita gambarkan dengan nilainya. Kita tuliskan dengan nilainya. Yang tidak diketahui kita tuliskan sebagai variabel. Dimensi-dimensinya juga harus kita tuliskan semuanya. So, in the correct free body diagram, you have to include all the forces which is happening to the system. Okay? The known forces, the known value, you're supposed to put it there. You're supposed to write down the known value there, like this: 200 Newton, 100 Newton, 600 Newton. But if the force is unknown, okay, you just put it as a variable, like this one, this way. Okay, don't forget to include the dimension as well. Okay, ada pertanyaan sampai di sini? Do any of you have any question about how to draw the free body diagram correctly? If not, then let's try to solve this together. Okay. The first thing that I want to solve is AY. Okay. The question here is we have to draw, we have to find out all the reaction force. So the value of AY. Hello? Yeah. Hello, hello. Okay. The value of AY, the value of BY, the value of BX. We have to find out those three values. Okay. Lilo. Hello, Lilo.
Yes, sir.
Okay, Lilo. I want you to find out the value of AY first. How can we solve that?
For answer, BY.
AY.
AY. I think we need to add all the vertical forces first.
Yes, you can do that, but at the same time, you have to solve BY as well, right? If you use sigma Fy. So basically, we have three unknowns, and we have three equations as well to solve this, right? Lilo, what are those three equations to solve for these three unknowns? Remember the equilibrium equation? Hello?
Yes, sir.
Do you remember the equilibrium equation?
I don't think so, sir.
You don't think so? I explained about this before. Okay, we have three equilibrium equation in a two-dimensional case. The first one is sigma Fx equal to 0, then sigma Fy equal to 0. The total force in the x direction is supposed to be equal to 0. The total force in the y direction is supposed to be equal to 0. And sigma moment equal to 0. We can use all these three. Okay, Lilo?
Okay, sir.
Okay, now, if I want to use sigma moment at point B equal to 0, what will I get there, Lilo?
Moment at A and the other moment.
What I want you to do is to represent this with all the forces. So I want you to to calculate Ay using this particular equation. Can you do that?
Oh yeah, I can do that.
How?
We set Ay as a variable and the other as numbers.
Yeah. So if I want to use sigma moment at point B equal to 0, so calculate sigma moment. So the total force is total moment at point B equal to 0. So what are those moments at point B? If the center of rotation is point B, what are forces here which will give a moment at point B? Lilo.
I think this one,
Okay.
this, and this.
Yes, correct. We have three forces which will affect the moment at point B, right? So we have those three. So because of 100 Newton, what are the moment which is caused at point B?
It's 200 because 100 times 2.
Okay, 100 times 2. So Newton meter. And it's the direction supposed to be counterclockwise, right?
Yes.
Okay, if we assume that counterclockwise is positive, then we have this one first. Okay, now, how about 600 Newton? Due to 600 Newton.
So it's 600 times sine of 45.
Sine 45
times 3.
Times 3. Are you sure that only 3? The center of rotation is B.
I'm sorry, 5.
5. Okay, so we have, and the direction is counterclockwise or clockwise?
Like this, counterclockwise.
Counterclockwise, so plus as well. We have 600 Newton sine 45 degrees and multiply by 5. Okay, what else? Because of 600 Newton. Remember, P is exactly in the middle of the beam in the thickness wise, right? P is exactly in the middle, but 600 Newton is actually happening on the top surface. And there is a 0.2 meter distance between the top and the middle.
Yeah, so it's 600 cos 45.
Correct.
Times 0.2.
Correct. Clockwise, counterclockwise?
It's clockwise.
Clockwise, correct. So it's minus 600 cos 45 degrees multiplied by 0.2 meter. Okay, so because of 600 Newton, you have to calculate. You have already calculated there. And now, because of Ay,
it's Ay times 6. 7.
So 7. Okay, Ay times 7. Okay, and the direction is clockwise or counterclockwise?
Clockwise.
Clockwise. So minus as well.
Mm-hmm.
Ay multiplied by 7 meter. And the total is supposed to be equal to what?
0.
0. Correct. Now you can see that we only have one variable, right? Ay. Can we solve for Ay?
Yeah, we can.
Yes, of course we can. Okay, so AY will be 200 Newton meters plus 600, 3000 multiplied by sin 45 Newton meters minus 120 cos 45 Newton meter divided by 7 like that. Okay, what is the value of AY? Yeah, 200 Newton meter plus 3000 sin 45 degrees minus 120 cos 45 degree and everything divided by 7 meter. What is the value of AY here? Hello?
Oh, wait, sir, let me calculate it. It's about 320, sir. 320 Newton meter.
Sorry, AY equal to 320.
320.
320 Newton, because you divide it by meter,
Oh.
right?
Yeah.
Okay, 320 Newton. Going up, right? After this, in order to solve for Bx and By, what we supposed to do, Lilo? Just now we already used the third equation here, sigma moment equal to 0.
We can use sigma Fy.
Sigma Fy equal to 0 in order to find which one?
Find By.
By, correct. Okay, we can use sigma Fy equal to 0 in order to find By. Okay, what are those forces which has a vertical component in our free body diagram?
Same as last time, sir. Like AY 600, 100, and 200.
200. Px, you can exclude Px, right? And now we have 200 Newton as well. Okay, so if you use sigma Fy equal to 0, what we will get there? Okay, if vertical is positive, so what we have there? If, sorry, going up is positive, so what we have there? Lilo.
We have 200 Newton, and then minus 600 times 40 times 45.
Okay.
And then minus 100 and minus 200.
Okay. So By, you put okay then. I think I will just make it easier for everyone, right? Okay. I will put By there minus By because By is going up. Sorry, By is going up. So plus By, then plus Ay. But Ay we have already known the value, right? So we can replace the Ay with its value, 220 Newton. Okay. Then we have 600 Newtons sin 45.
I think it's minus, sir.
Yeah, minus, correct. Because it's going down, minus. And then we have minus 100 Newton. And the last one is minus 200 Newton equal to 0. Correct, right? So if you calculate what is the value of Py? Lilo.
Okay, wait, sir. It's about minus 404 Newton.
Minus 404 Newton. The value of Py is minus. Okay, sorry. Minus, are you sure? Minus, it's supposed to be plus. Because you're supposed to move it to the right side, right?
Oh, yeah.
Plus, right?
Yeah, that's right.
Plus 404 Newton. So the direction of our free body diagram, the direction of Py in the free body diagram is correct. It's going up. 404 Newton going on Py. Okay. Last one. We have to solve for Bx. How are we supposed to get it?
Yeah, we can use sigma fx.
Sigma fx equal to 0. The last one is sigma fx equal to 0. So we have to take a look which of these forces which has a horizontal component. What are those, Lilo?
The 600 cos 45
Okay,
and bx.
Bx, correct. So if going to the going right is positive. So what we have is what? Can you let us know? Is if going right is positive.
Also, it's 600 cos 45
Okay, correct.
plus dx equals 0.
Cos 45 degrees plus Bx equal to 0. So our Bx will be minus 600 cos 45. So what is the value of Bx?
It's 424 Newton.
Yep. So this is our results. Ay is 320 Newton. Py is 404 Newton positive. Bx is minus 424 Newton. Okay. Minus means the direction is the opposite than the direction in free body diagram. So basically, just now Bx, I draw it as it going to the right, but in reality, it's supposed to be going to the left with value of 424 Newton. Okay, Lilo?
Yes, sir.
Okay, thank you very much. So basically, this is how we solve. This is step by step on how we solve the problem, the equilibrium problem. So the first thing that you're supposed to do is to draw the free body diagram. Okay, draw the free body diagram by replacing all the constraint with reaction force, which is caused by that constraint. After you draw the free body diagram, then take a look at the unknowns that you have in the free body diagram. In this case, we have three unknowns: Ay, By, and Bx. In order to solve for three unknowns, we have to have three equations, and we have three equations. We have three equilibrium equations: sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. By using the first one, by using sigma moment at B equal to 0, this one, sigma moment at B equal to 0, I found out that, Lilo found out that Ay is equal to 320 Newton. Then, by using sigma fy equal to 0, Lilo found out that Py is 404 Newton. And lastly, by using sigma fx equal to 0, okay, Lilo found out that the Px is equal to minus 424 Newton, which means the direction here is actually supposed to be the opposites of the actual direction is supposed to be opposite of what we draw here. So instead of going to the right, it's supposed to be going left. And the value is 424 Newton. Any question about this? So while waiting for the questions, I will re-explain it in bahasa. Okay. Jadi urut-urutannya untuk menyelesaikan suatu permasalahan kesetimbangan itu adalah gambarkan diagram benda bebasnya terlebih dahulu dengan cara mengganti constraint-constraint yang ada dengan gaya reaksi yang diakibatkan oleh constraint tersebut. Contohnya di Px dan Px, Py, Ay. Ya. Nah, kemudian setelah itu gambarkan semua gayanya, lihat unknowns dan juga knowns value-nya. Di sini bisa terlihat bahwa unknowns-nya itu ada 3, yang tidak diketahui ada 3, Px, Py, dan Ay. Sehingga kita butuh 3 persamaan. Nah, kita punya 3 persamaan. Kita punya persamaan sigma fx, sigma fy, sigma moment, persamaan equilibrium, untuk menyelesaikan ketiga variabel yang kita tidak ketahui nilainya. Menggunakan sigma moment di B sama dengan 0, Lilo tadi mendapatkan bahwa AY-nya sama dengan 320 Newton. Menggunakan sigma fx sama dengan 0, Lilo dapat bahwa Px-nya minus 424 Newton. Pakai sigma fy sama dengan 0, Lilo dapat Py-nya 404 Newton. Seperti itu. Ini arti dari minus 424 Px minus 424 Newton ini artinya adalah yang kita gambarkan ini arahnya kebalik dari yang seharusnya. Jadi di situ kita gambarkan ke arah kanan, padahal seharusnya adalah nilainya itu 424 Newton, tetapi arahnya ke kiri. Cuman nggak ada masalah, tidak perlu digambar itu. Kita tuliskan aja bahwa minus di sana itu artinya adalah arahnya seharusnya berlawanan dengan arah yang kita gambarkan di free body diagram. Seperti itu. Silakan jika ada pertanyaan. Okay. Is there any question here?
Pak, saya izin bertanya, Pak.
Silakan, Raka.
Di penghitungan sigma momen di B sama dengan 0 itu, Pak, saya masih kurang paham yang di titik 600 cos 45 dikali 0,2 itu loh, Pak. Itu muncul dari mana?
Bukan 6,2 itu. Tulisan saya kejelekan ya. 600 cos 45 dikalikan 0,2. Bukan 6,2, 0,2. Nah, 0,2 itu munculnya dari sini. Ini ya, ini kelihatan ini, 600 Newton. 600 Newton itu kan diberikannya di ujung atas. Kebayang nggak ya? Itu peletakan gayanya itu ada di ujung permukaan atas di sini. Padahal titik tersebut ke titik tengahnya itu ada selisih 0,2 meter. Dan perlu diingat ya, tadi kita menghitung sigma moment itu di titik B. Titik B itu pas di tengah-tengah. Jadi, lengan momennya itu ada double. Ada lengan momen 5 meter dari titik B ke titik 600 Newton itu. Ada lengan momen yang 0,2 meter. Lengan momen yang horizontal dari B ke 600 Newton, itu lengan momen yang horizontal ya. Kemudian itu 5 meter. Sedangkan dari B ke 600 Newton itu ada lengan momen vertikalnya. Ini kan kalau kalian, ini kan di sini kan ya. Ini kan nggak pas, nggak segaris kerja gaya kan ya, gaya horizontalnya. Akan menyebabkan momen, betul nggak? Halo?
Oh iya, Pak. Itu seperti ini, Pak. Kayak kita gunakan Varignon theorem.
Ya betul, Varignon theorem. Jadi, oh ya betul. Ini harusnya tadi digambarkan dulu ya. Ini kita pakai Varignon theorem. Jadi, si 600 ini dibagi menjadi 2. 600 sin 45 derajat. Dan juga yang satunya lagi, ini di saya. Salah. Yang satunya lagi adalah 600 cos. Ini adalah 600 cos 45 derajat. Kebayang ya? Yang 600 sin 45 derajat, lengan momennya 5 meter. 600 cos 45 derajat ke titik B itu lengan momennya 0,2 meter. Gitu ya, Raka ya?
Iya, Pak. Terima kasih, Pak.
Sip. Ada lagi yang bertanya, silakan.
Pak mau tanya.
Ya, William.
Jadi gaya reaksi itu adalah
You're supposed to speak in English.
oh sorry. So the reaction force which happens in a point A or B, the direction is always the opposite of the resultant force in the X or Y component, right?
The direction is always
The opposite of the resultant force that acts on the point, either on the X or the Y component.
not necessarily. So you have to calculate for the total force. So we cannot conclude it like that. So you mean like at Py, so at P, there is a Py. Py is going up because 200 Newton is going down. You mean like that, right?
No. For example, all of the forces that are on this system, on the X component is going right at 100 Newtons, for example. So the reaction force on the X component is 100 Newton to the opposite direction, right?
Yes, correct. That one is correct. Yes. So for example, in this case, Py, our total force of Py is, Px, right? Px is 424 Newton. If you sum all the horizontal forces except for Bx, okay, if you sum all the horizontal forces except for Bx, okay, the total force is supposed to be going right 424 Newton. That's why Px will have 424 Newtons going to the left. That's correct. But the same thing is not supposed to be the same for Ay and By, because Ay and By, there are two forces, right? The total of Ay and By, yes, it will be the same as the total of all the forces, all other forces, all other vertical forces. Because we have two forces. You understand what I mean, right?
Yes,
Hello?
sir. Yes.
Yeah, you can only say that when there is only one reaction force in that direction, like Px. But if we have two forces like Ay and By, like that, the total of both will be the same as the total of all other vertical forces, and it will be the opposite direction of that. Yes, correct. Okay.
Thank you, sir.
Any other question?
Excuse me, sir.
Yep.
I still don't understand why AY exists and AX doesn't exist.
Oh, okay. AX, it's mainly because of this, Aurelia. Later after this, I will re-explain about the constraint. You can see, right? The type of constraint at P is a pin joint, correct, right, Aurelia?
Oh, I see. So it's different. I thought it was the same.
Yes, it's different. So it's a pin joint. When we talk about pin joint, it can restrict movement in the X direction and Y direction. That's why we have to put Bx and By there. Because the restriction, we're supposed to put the restriction in terms of force. In this case, it's Bx and By. Okay. On the other hand, when we take a look at A, okay, it's a roller joint. When we talk about roller joint, okay, when you give a horizontal force at the roller joint, it will slide, right, Aurelia?
Yes.
So there is no restriction in the horizontal force. Because of that, there will be no AX there. But at the same time, if you push it, if you push vertically, the roller joint will withstand it. So there will be a vertical reaction force, AY. So that's why I only put AY there. And there is no AX there because it's a roller joint. Okay, Aurelia?
Okay, thank you, sir.
So basically, all the external forces you're supposed to see, you're supposed to base the external forces that you draw in the free body diagram on the type of the constraint that you have in the problem. If it's pin joint, there will be vertical and horizontal forces. If it's a roller joint, only vertical force. Okay. I think in that case, Wait a minute, stop share and I will reshare again for other thing. Yep. I need to explain to you guys about the type of constraint. Okay, there are several type of constraint. Okay, when we talk about cable, okay, remember when we talk about cable previously in the previous problem. I think I'll just share screen. Okay, remember when we talk about cable in the previous problem. This one, okay. When we have cable like that, okay, the force that we're supposed to represent to replace the cable is actually in the same direction as the cable. So, for example, if we want to replace CD here, cable CD here with force which is representing the cable CD, then the force is supposed to be going in the same direction as the cable, like this. And it's supposed to be always tension, in tension. Then AC, the direction is supposed to be the same as the cable. FAC is supposed to be the direction is supposed to be the same as the cable, FAC there. And then PC, FPC, the direction is supposed to be the same with the cable. And it's always tension. Okay, that's the thing about cable. So that's the first the first thing that you're supposed to know. Drawing the cable. You can see, right? If we have if we have things like this, there is a beam, and there is a wall here. The cable is connecting the wall with the beam, okay, and the cable is straight like that, okay. Then what you're supposed to draw there is the force which is representing the cable, okay. It's supposed to be tension at the beam, and the direction is supposed to be the same as the direction of the cable. It's always tension, okay. And then if the cable is with a weight and the weight is not negligible, okay, the direction of the tension force is supposed to be the tangent here, okay, the tangent there. So this is supposed to be the direction of your tension force because of the cable, okay. But this particular problem is quite rare in our case. Most of the time, we always ignore this part, okay, for your static problem. But in the intermediate or advanced problem, sometimes we do this. In most of the time, in the real world case, we cannot ignore the weight of the cable. But in our statics problem, we can ignore the weight of the cable. That's why it's always straight like this. Next one, smooth surface. When we talk about smooth surface, and this is the system that we want to draw. Okay, if this is the system that we want to draw, only the part of the sphere here is the system that we want to draw. Okay, if it's smooth surface, then how we draw the free body diagram of the sphere is we draw the sphere, and the smooth surface there, we replace it with vertical force, normal force, like that. The opposite is the rough surface. If it's rough, okay, if it's rough, the rough surface there, we can replace it, okay, we can replace it with normal force and friction force. Okay, that's why it's slightly different. It's slightly different. Smooth surface and rough surface is slightly different. When it's smooth, okay, it's only only normal force is happening there. So you can replace the smooth surface with normal force. But rough surface, you have to replace it with normal and friction force. Okay, remember, when you draw the free body diagram, you are not supposed to draw the constraint anymore. So for example, like this, okay, you are not supposed to draw this part anymore. The cable, you are not supposed to draw the cable anymore. And the constraint here, you are not supposed to draw anymore. So you just replace both of those with the tension force from the cable. The same as this one, you can see, we are not supposed to draw the smooth surface anymore. We replace the smooth surface with the normal force. Or this one, we remove the rough surface with normal and friction force. Like that. Okay. This is an example of a cable problem. You can see it's straight, right? In our real world. Okay, so we can represent the cable there with tension force like this. Okay, now this is what Aurelia asked just now. When we talk about roller support, the roller support can be in the shape of this, or this. Those three shapes, we normally consider that as a roller support. When we talk about roller support, okay, roller support can withstand movement in the vertical direction. It can withstand the movement in the vertical direction. Okay, roller support itu bisa menahan pergerakan ke arah vertikal, tetapi dia tidak bisa menahan pergerakan ke arah horizontal. But it cannot withstand the movement in the horizontal direction. That's why we do not need to put the horizontal reaction force there. We only need to put the vertical reaction force, normal force there. Okay, the same as freely sliding guide. Okay, is quite close to a roller support. It can only withstand the vertical direction movement. So we will only give vertical force to replace that freely sliding guide. We don't have to add the horizontal force there. Okay, untuk freely sliding guide ini sifatnya sama seperti roller support ya. Dia tidak bisa menahan pergerakan ke arah horizontal. Jadi kita tidak perlu memberikan reaction force ke arah horizontal. Hanya perlu memberikan reaction force ke arah vertikal. Seperti itu. Okay, the same here. Okay, when we talk about support and we talk about the free body diagram, okay, in the free body diagram, you are not supposed to draw the support anymore. What you need to do is just to replace the support with the forces which are representing the support. In this case, it's normal force only because it's a roller support. The same as this one. You are not supposed to draw the support anymore. Okay. What you need to draw is just the force representing the support. Okay. This is the example of roller support in our real life. Normally, we have it in one side of the bridge. Okay. One side of the bridge is normally like this. We have a roller support like this, or like this. Okay, now the next one is pin connection. Okay, pin. When we talk about pin, there are two types of pin. Okay, the first type of pin is when there is no friction in the pin itself. When there is no friction in the pin, which means that the pin will not be able to withstand rotational movement. Okay, the pin will not able to withstand rotational movement. In that case, it will only be able to withstand the vertical and horizontal movement. That's why we can replace the pin with vertical and horizontal force like this. But if the case is pin with friction, okay, pin with friction, which means that the pin is withstanding the rotational movement as well. Now it can withstand vertical movement, horizontal movement, and rotational movement. That's why you have to put three forces. You have to put reaction force x direction, reaction force y direction, and moment like this. This is only the case for, this is on, you need to draw the free body diagram like that if the pin is stated, if the problem stated that the pin is, has a friction there. But if the pin is frictionless, and most of the time the pin is frictionless, then you just need to draw it like this. Most of the time, this is what we draw for pin. Okay, unless it's stated that the pin has friction, then you draw it like this. So most of the time you have to draw it like this. Okay, now last one is fixed support. Fixed support is like a cantilever. Okay, so at one end, all the parts of it is fixed. So in that case, it will be able to withstand the horizontal movement, vertical movement, and rotational movement as well. Okay, it's like this or like this. When there is a welding there, it means it's fixed support, or built in like this. You put it inside of the concrete like that, then the restriction is in all the direction, vertical, horizontal, and moment. So you're supposed to replace those kind of support with this sigma fx, fy, and moment. Okay, this is example of pin support at the bridge. Okay, normally one side of the bridge will be like that. It's a pin support, and the other side of the bridge will be a roller support like this. Okay, this one is pin support as well. Okay, and this is the example of a cantilever or a fixed support or built-in like this. This is fixed support. Okay, this one is because it's welded, it's a fixed support as well. This one is the same, it's fixed support as well at the same, because it's welded. Okay, when we see this kind of problem, we can see now, oh, in this kind of problem, we have a fixed support at the end here, then we have a fixed, we have a cable here. Okay, so if we want to draw the reaction force which is happening at the balcony there, then we can see that basically it's just a fixed support at one end, and then cable at that particular point. Okay. Any question about the this support things and how to represent the forces? Actually, one more thing is gravitational force. Okay, and spring. When we talk about gravitational force, we have to draw it in the free body diagram as well. Because if something has a weight, then we have to draw it in free body diagram. So if I have a stone like that and it has a weight, it has a mass, and it has a gravitational force, then we're supposed to draw the gravitational force at the center of gravity. At the center of gravity, which is equal to the mass multiplied by the gravity, like that. And when we talk about spring, okay, normally we always talk about linear spring because we talk about a basic problem, right? Linear spring. Okay. Normally we will have to replace the spring with a force at the same direction as the spring. And the magnitude of the force, it depends on the contraction of the spring, like this, the X. There. This is some of the example on how to draw the free body diagram. Later we will talk about it. But up until this, anyone here want to ask question? Anyone? Anyone want to ask question, please? Okay, no question on this. Okay. In that case, let's practice on how to draw the free body diagram again. Okay. Aurelia again, because just now you are asking me about the pin and roller. Hello, Aurelia.
Yes, hello.
Okay, please help me to draw the free body diagram of the number 1. Remember, we only draw the external force and reaction force only, or gravitational force. How to draw it?
Are the lines ropes or what?
Which one? This one?
Yes,
Oh,
those lines.
Those one are small beams, and you don't have to. You can ignore that because we don't want to talk about that yet.
First,
Okay.
draw
So basically, you can just draw the outside body. Okay, Aurelia. Okay, but I want you to complete this then. What else are we supposed to draw there?
force P at
Force P?
the top, yes.
What else?
At A, I'm sorry, I don't memorize it. Is a roller pin or
No, this one is pin.
just a normal pin?
Yeah.
Okay. So there's AY and AX.
AY, AX. How about FB?
Is B a roller pin?
Yeah, it's a roller pin.
So there is AY.
EY then, yeah. Okay.
BY, yes.
Okay, thank you, Aurelia. Next one, I want to ask for Benedictus Rahadian.
Yes, sir.
Okay, Benedictus, please help me to draw the free body diagram of number 2, the second free body diagram. Remember, it's known that it has mass M there.
So there's F1, F2, F3, and
Okay,
on
so
the
first
middle,
you have to draw the beam.
yes, the beam first.
Don't forget about that. Okay. After drawing the beam, then what you need to draw?
The F1,
F1,
F2,
F2.
yes, and on the middle, another force, the from the mass.
Sorry, the weight of the beam.
Okay, at the center, the
Yeah.
center of the gravity. Okay, COG.
Yes.
When we talk about COG, that if the COG is there, then we have the weight,
Yeah.
which is equal to mass multiplied by gravity. Okay.
Yes.
Okay. What else?
F3 for x-axis and y-axis.
Which at which point?
At F3 point.
Oh, yeah, not necessary. You can if it's needed, then you can use the Ferrignan theorem to divide it into f3x and f3y, right? But for the free body diagram, not necessarily you have to do it from the beginning. Okay, you can do it later when it's necessary. At point A, what are you supposed to draw there?
AY.
AY. What else? What kind of support here? What kind of support that we have there?
I'm not really sure.
You're sure? Just now I already explained it, Benedictus. It's a built-in or fixed support. Okay, let's check again. This one, right? Number 7, right? Like number 7, right?
Yes.
Okay, so it's built-in or fixed support. So it's fixed actually. What does it mean? This kind of support is restricting all the movement. So it will not be able to move in the x direction. It will not be able to move in the y direction, and it will not be able to rotate as well. Okay. So what reaction force that I supposed to put at A? Hello, Benedictus?
Yes. Sorry, sir, I'm not really sure.
So
Little
at
bit
A
confused.
is a fixed support, right?
Yes.
Fixed support means the restriction is in the x direction, y direction, and rotation. It will not be able to move in the x, y, and rotation. So in that case, when it's restricted to move in the x direction, then what kind of force that we're supposed to add there? Of course, we have to add the x reaction force then, right? This one will restrict the movement in the x direction, correct, right? Hello, Benedictus?
Yeah, I guess.
Okay, and we have to add y direction as well. Y direction reaction force, AY, in order to restrict the movement in the y direction, right?
Yes.
And you have to add moment as well, in order to restrict the rotational movement. So basically like this, Benedictus. Benedictus, okay? When we draw the reaction force, what you're supposed to do is take a look at the support. What kind of restriction that the support give to the system? That restriction must be represented by force or moment. Do you get it, Benedictus?
Yes, sir.
Okay, like point A here at the number 1. Just now Aurelia replaced the pin support there with AX and AY. Why it's like that? Because pin A is restricting the movement in the X and Y direction. That's why we have to represent that restriction in force AX and AY. Do you get it?
Yes, sir.
And now at B here, it's a roller support. Okay, roller support only restrict the movement in the vertical direction. That's why C only add vertical force, vertical reaction force there. Do you get it?
Yeah.
Yeah.
Right.
Now, if it's fixed support, okay, if it's fixed support, it restricts the movement in horizontal movement, vertical movement, and rotational movement. Like you clamp it, okay? Fixed support is like this. Like I clamp it totally. It is not able to move horizontally. It is not able to move vertically, and it is not able to move rotationally as well. You get it?
Yes, sir.
So you have to represent that into the reaction force and moment. Okay, the restriction in the x direction, you can represent it with ax, right? The restriction in the y direction, you can represent it with ay. The restriction in the rotational movement, you can represent it with ma. Do you get it, right?
Yeah.
So everything depends on the type of the support, Benedictus. Okay.
All right.
Basically, what you're supposed to do is just to memorize it. Okay, fixed support, the reaction will be like this because it restricts those three movement. Pin support, the reaction will be like this. Roller support, the reaction will be like that. Okay, because actually most of the time we will only use these three supports plus rough surface and smooth surface. So only those 5 supports that we need to use actually. Do you get it, Benedictus? So try to practice more in order for you to get used to it. Okay.
All right, sir.
Good. Okay. Now, also I want you guys to practice as well the type of support. Amadea. Hello, Amadea.
Yes, hello, sir.
Okay, Amadea. I want you to help me to draw the free body diagram of number 3, Amadea.
Okay, so we start with a slanted line.
Okay, so that's the answer. We always start with the main body, okay?
Yeah, and then a horizontal force coming
P.
from the left end, P.
What else?
I think there's an upward force at B.
Yeah, but
yeah.
start with this first, okay? Moment, right?
Oh, right, okay.
We have moment here, clockwise, M. What
Oh, yeah.
else? At B?
Upward force.
Yeah. Okay, this one, right? So the system is slightly like this. Okay. At B, you there is a pin at B. So they're supposed to be what?
Upward and horizontal force.
Yeah. Vertical and horizontal force. Actually, for B, you can represent it like this. Px, Py like that. But you can also represent it like this. Slightly slanted. This is my Px. This is my Py. You can do it that way. Why you can do it that way? We can assume that instead of having a coordinate like this, x and y, what we have is having coordinate like this, x and y. Okay?
Okay, so wait, so does that mean the force at B is not like horizontal?
Yeah, so now my horizontal is like that.
Oh, okay, okay.
Do you get it, right?
Yeah.
So
now the P is like slanted.
Yep, slanted like this. So basically, your x and y is up to you guys. Yeah, the coordinate of your x, the x direction and y direction. So your coordinate is actually up to you guys. Just choose the direction. Just choose the coordinates which will help you to solve the problem. Okay, so you can use this kind of coordinate. Basically, the main important point of px, py in the pin joint is as long as both are perpendicular to each other. So as long as you put both perpendicular to each other, whatever direction that you want to use is supposed to be okay. Do you get it? Hello?
Yes, yes.
Okay. Amadia, now what else that we have here, Amadia?
I think we can do the same at A. So there's AY.
Remember, it's smooth surface.
Oh, wait.
Smooth surface, will there be any friction at smooth surface?
No.
No. So at smooth surface, there will be only one. I will remind you again, no problem. This one, smooth surface and rough surface, right? We are talking about smooth surface. So smooth surface, we will only have what? This one, normal force. Okay, normal force to the contact area. Okay, Amadia?
Okay, so wait, so that's just AY, right?
That's correct, just AY.
Oh, okay.
Just AY, and the AY is supposed to be normal to the contact area, like this. AY. Okay? Amadia?
Okay.
Okay, what else? Remember what?
The weight.
The weight. Where are you supposed to put the weight?
At the center.
Center of gravity. So you put it at the center of gravity here. If that's the center of gravity, then we have the weight here. This is our weight. Is equal to M multiplied by G. Okay, Amadia?
Okay, sir.
Is it complete now? Yes, it is. It is complete. So it's supposed to be okay. Okay. Thank you, Amadia. For number 4, I think I will delay it a bit because it's slightly complicated, and we will discuss about it next time. I just want to discuss about the simpler problem first. Okay, this one is just example. Okay, thank you, Amadia. And then after that, so for today, I want to concentrate on the drawing of the free body diagram. Okay, so this is basically our schedule. So actually last week we're supposed to concentrate on the drawing free body diagram, and but for today I will concentrate on the drawing free body diagram first. Then for tomorrow I will give you some practice on how to calculate the equilibrium. Okay. Okay, let's try to draw the free body diagram again. Now this one. Diva Dwi Cahyo. Halo Diva.
Yes, sir.
Oke, untuk menyelesaikan ini bagaimana, Diva? Ini kelihatannya mungkin permasalahan terakhir yang kita akan bahas hari ini ya. Silakan Diva, kalau menurut kamu cara menyelesaikannya bagaimana? Silakan. Halo Diva.
Oke, sir. Approach ke normal force.
Diva, kamu tuh kelas internasional atau kelas reguler ya?
Regular.
Oh, reguler. Oke, ya udah.
Ya.
Terserah kamu. Kalau kamu lebih nyaman pakai bahasa Inggris silahkan. Kamu pengen nyoba pakai bahasa Inggris silahkan. Pakai bahasa Indonesia juga boleh.
Aduh, saya masih agak bingung ya, Sir. Delete below P.
Coba dipahami dulu, oke? For the others as well, I want you guys to try to understand about this problem first. So this is the problem that we want to try to solve today, okay? And after that, then I will dismiss the class. So there is a truck there. There is a small truck there, and the truck has its own weight actually at G, okay, at center of gravity G, and the weight is 3,600 lbf, okay, and the question is determine the load weight WL for which the normal force at wheel A and wheel B will be the same. Oke, kelihatannya mulai dari membuat diagram benda bebasnya dulu saja, Diva. Jadi, so it's like this, okay? Whenever you are confused about the problem, don't just stop there. Try to draw the free body diagram first, because by doing so, maybe you will understand more about the problem. And when you draw the free body diagram, try to state the known value and the unknown value. Okay, then after that, solve it. Oke, silakan nih Pak. Kalau kita mau menggambar diagram benda bebasnya gimana? Apa saja yang ada di sana?
Kayaknya ada gaya ke bawah, ya nggak, Sir? Dari
Kita gambar dulu truknya ya. Pasti kita gambar truknya kan. Terus ini ada roda di bawah. Terus ke sini. Ke sini. Gambar saya agak jelek ya. Ada roda lagi. Maju dikit. Ya, ini truk secara keseluruhannya kayak gitu ya. Oke. Gaya-gaya yang diketahui apa saja, Diva? Yang sudah diketahui benar-benar. Ini di G di sini ada ya. Itu ada apa yang diketahui di situ? Halo?
I think there's gravity, nggak, Sir? Ada
Yeah,
yang
weight,
3.600 weight ya.
The weight, okay. The weight there is going down 3,600 lbf. Okay, we just use lbf there. Okay. What else that we have there? Beside the weight, what else that is known or unknown there?
Berat yang WL itu, Sir, ke bawah. Berat pasir ya. Ngarah ke bawah ya nggak?
Oke, WL. Oke, apa lagi yang diketahui? Ada gaya apa lagi?
I think there's normal force.
Normal force di mana?
In the rear, di bannya.
Oke, di ban. Sini ada AY. Di ban yang belakang ada juga ya?
Iya.
BJ. Lalu apa lagi yang diketahui di situ? Ingat ya, diagram benda bebas itu harus lengkap. Apa saja yang diketahui di sana?
Jarak.
Dimensi ini diketahui tidak?
Jaraknya.
Jarak, oke. Dari sini ke sini 45 inci ya. Dari sini ke sini 67 inci. Dari sini ke sini berapa?
16.
16 inci diketahui juga. Oke, apalagi yang diketahui di situ? Sudah ya, cukup? Atau ada lagi?
Kayaknya itu aja deh.
Oke, nah sekarang lanjut. Oke, dari soalnya, apa yang kita bisa lihat di sana? Apa yang kita bisa ketahui di sana?
The normal force dari ban depan sama belakang sama, Pak.
Artinya apa?
Berarti AY sama dengan BY.
AY sama dengan BY ya. Ketahuan itu ya. So, from the problem, we know that AY is equal to BY. Okay, in that case, then we can replace one of the unknowns there, BY, for example, with AY. Correct, right?
Iya.
It's supposed to be okay for me to do this, right? Bener ya?
Ya, bisa, Pak.
Nah, sekarang, unknowns-nya ada berapa?
Ada 2.
WL sama AJ saja ya?
Iya.
Oke. Unknown. Yaitu WL, AJ. Oke. Kemudian, equilibrium equation kita yang bisa kita gunakan apa saja?
I think sigma F sama dengan 0, Pak.
Sigma F arah kemana?
Kenapa?
Sigma F yang arah kemana? Jangan cuma ngomong sigma F. Oh, ada 2 kok sigma
Oh,
F.
sigma FY.
Oke. Equilibrium ya. Oke. Kita bisa pakai sigma FY sama dengan 0. Sigma Fx kita bisa pakai tidak?
Nggak ada gaya yang di X sih sepertinya.
Tidak ada gaya ke arah horizontal. Jadi sigma Fx-nya sama dengan 0, itu kita tidak bisa pakai. Lalu apa lagi yang kita bisa pakai?
Moment.
Ya, sigma moment bisa kita pakai. Sigma moment equal to 0. Sigma moment equal to 0. Now, the next question is, how many unknowns and how many equations that we have? Jumlah jumlah variabel yang tidak diketahui jumlahnya berapa? Jumlah persamaan yang kita punya berapa?
Ada 2 persamaan.
2 persamaan. Unknowns-nya?
Unknowns-nya ada 2 ya, juga.
Bisa diselesaikan tidak?
Bisa.
So, we have 2 unknowns, WL and AY. We have 2 equations to solve it. Sigma Fy equals 0 and sigma moment equals 0. In this case, which means it is solvable. Okay, now try to solve it. Which one that you want to use first?
Pakai sigma M-nya dulu deh.
Sigma moment. Oke, di mana?
Sigma M sama dengan
Ya, nggak maksudnya sigma moment terhadap titik yang mana? Kita harus tentukan.
terhadap G.
Terhadap G. Kalau terhadap G, ini saya kasih tahu dulu ya. Kalau terhadap G nanti akan muncul AY sama WL kan ya? Isinya variabel doang gitu. Bener nggak?
Iya.
Nah, ini saya sambil ajarin. Oke, I will teach you guys on how to use which equation first, and for the sigma moment, where you supposed to put the center of rotation. Okay, whenever you use sigma moment at one particular center of rotation, okay, the force at that particular point will be nullified because the moment arm will be equal to 0. So try to use that for your benefit, the sigma moment especially sigma fy and sigma fx equal to 0, you cannot do anything about it. But for sigma moment, you can choose any point that you want as the center of rotation and try to eliminate the unknowns there. So try to choose. This is one of the easiest way to do it, right? How to choose the center of rotation for sigma moment. Okay, try to choose the center of rotation in which you will eliminate as many unknowns variable as possible. Ngerti nggak nih maksud saya?
Iya, ngerti Pak.
Nah, nah, kalau kayak gitu enaknya di mana?
So I can use the WL for the center of rotation.
Okay. You can choose this particular point as you can choose this particular point as your center of rotation. Because at that particular point, you will be able to eliminate the WL, and you will be able to solve for AY. But if you use that at this particular point, for example, okay, you will be able to eliminate AY there, but still there is another AY here, right? So AY will still be there, WL will still be there. You will not be able to solve it directly. So just correct in this particular problem, in order to make it fast, in order to solve it fast, okay, the easiest way is to use this point as your center of rotation for sigma moment, because you will be able to eliminate WL and you will be able to solve AY directly. Okay, jadi kita pakai sigma moment di WL sama dengan 0. Oke, sekarang persamaannya jadi gimana?
Sigma moment sama dengan
sama dengan apa aja? Gaya apa saja yang ada di situ?
Kalau searah jarum jam itu negatif atau positif? Negatif.
Bebas, bebas. Kamu bisa menentukan ini positif negatif dari awal. Bisa clockwise positif, bisa counterclockwise positif. Hasilnya akan sama aja.
Oke.
Asalkan konsisten, ya. Jadi kalau misalkan clockwise positif, kamu pakai yang mana dulu?
Kalau clockwise positif, AY kali 45.
AY kali 45 center of rotation-nya di
I'm sorry. I mean, wait. 73. AY yang pertama dikali 128.
Ya, 45 tambah, oke. 45 plus 67 plus 16.
Ya.
Oke. 128 ya, 128. So AY multiplied by 128 inches. Okay, clockwise, so it's positive.
Yes.
Then what else do we have?
And then AY again times by 16.
Okay, plus AY times 16 inches. And then what else?
Then 3,600 times 83.
67 plus 16, 83. Okay. Minus 3,600 LBF multiplied by, sorry, just now, what's that?
83.
83 just equal to 0, like that, right?
Yes.
Okay, now what is the value of AY? Ya, harganya AY-nya jadi berapa? AY-nya jadi berapa?
AY equal to 2,075.
3,075.
2,075.
2,075 LBF from this equation. AY is solved. Then After that, you can use sigma Fy equal to 0 in order to solve for WL. Oke. Hasilnya bagaimana? Sigma Fy sama dengan 0.
Sigma Fy sama dengan AY plus AY minus 3600
Minus
LB.
minus WL ya.
Iya.
Oke, berarti AY plus AY minus 3600 LBF minus WL sama dengan 0. AY-nya sudah diketahui ya. We know the value of AYOED. So just replace this with the value 2075 LBF plus 2075 LBF minus 3600 LBF minus WL equal to 0. So we will be able to find WL. What is the value of WL there?
550.
550 LBF. So this is the answer there. Oke, Diva, paham ya?
Iya, paham, Pak.
Jadi, so for every one of you, okay, if you don't know the solution yet, don't just give up. Okay, try to draw the free body diagram first. And then after that, try to implement everything that you know from the problem, okay, in the free body diagram. Then try to list the unknowns and try to list all the unknowns, and then try to list out all the equation that you have. If the number of equation and the number of unknowns match, then you can solve the problem. Okay. Always start with drawing the free body diagram and try to put as complete as possible information in your free body diagram. Okay. Anyone want to ask question about this before I dismiss the class? Anyone? Chai Sarendi. Hello, Chai Sarendi.
Yes, sir.
Do you understand about this?
Yeah, I think so far so good.
Okay, good. How about Fatimah Nadine?
Yes, sir.
Do you understand?
Yes, sir.
Okay, good. Okay. In that case, I think that's all for today. Tomorrow, we will continue with the more problem example. So we will try to draw the free body diagram together and solve the free body diagram together as well. Okay, solve the problem together as well. Okay, I think that's all for today. Okay, see you guys tomorrow at 7 in the morning. Okay, don't forget to wake up early tomorrow. Yeah, Alberto, yes.
Thank you, sir.
Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
See you tomorrow. Bye.
Thank you, sir. Thank you, sir.